Okay, this is not how I want to do this lesson, but, you know, when stuff happens, yeah, you gotta adapt and adjust. And my computer is being extremely slow this morning. I have the spinning wheel of death. How wonderful. Okay, so we are going to start a new chapter. It is titled Chemical Formulas and Chemical Compounds, and I'm actually going to spend quite a few days on section 1 with chemical names and formulas. So I'm going to explain the significance of a chemical formula, and then we're going to focus in on ionic compounds and how to name ionic compounds. So the significance of chemical formulas really has to do with letting you know how many atoms or what types of atoms are in a compound. And so they tell you the number of atoms, they tell you the kind, and the thing I want to stress is that in molecular compounds, so those usually with covalent bonds, it tells you the exact number of atoms of each element in that single molecule of a compound, okay? Whereas with ionic compounds, remember, it's the simplest ratio. It's a formula unit, and it's the simplest ratio of the cations and the anions. So remember, with our ionic compounds, we have positive ions, cations, with negative ions or anions, and they are arranged in that crystal lattice, however you want to pronounce it, structure, where, you know, positives with negatives, and it sets up this nice structure. Okay, so monoatomic ions are made of only one type of atom. And so our main group elements, groups 1 and 2, and then 13 through 18, they tend to gain or lose electrons to form those ions. So groups 1 and 2, they tend to lose 1 and 2, and that's why you see in my periodic table the +1 and the +2. Groups 15 through 17, those are nonmetals, and if you take a look, they tend to gain electrons, and they have negative charges. So group 15 is a -3, group 16 is -2, group 17 is -1. Silicon and carbon tend to share, so that's why it's just a 4 above my periodic table, and metals tend to lose, and they have plus charges. So naming monoatomic ions differs between positive, like cations, and negative ions or anions. So when you name a positive ion, okay, a cation, basically you state the element's name, and then you just say cation at the end. So K+ with the +1 charge, potassium cation. Magnesium +2, magnesium cation. When you name anions, okay, you actually have to change the ending to IDE, and then you add anion. So fluoride anion, nitride anion, okay? So cations, leave the element's name alone and just add cation at the end. For negative or anions, you drop the ending, change it to IDE, and then anion. So here are some common monoatomic ions, okay, and they change the endings for your negative ones, but the positive ones, you would just say lithium cation, sodium cation, potassium cation. Down here it's fluorine, but we change the ending to IDE, so it's fluoride. Chlorine, drop the INE, change it to IDE, chloride. Bromine, bromine is now bromide, anions, and don't forget the anions at the end. Okay, so binary compounds are those that have 2 elements in it, and when we deal with ionic compounds, the total positive and negative charges have to be equal. So potassium and iodine. If I take a look at my periodic table, okay, potassium is group 1, it's got a +1 charge. And then we have iodine, group 17, -1. So the charges there are going to balance out really nicely. So I would just say potassium iodide for naming that one. Okay, potassium iodide. Sodium and sulfur. So sodium's in group 1, that's a +1. Sulfur is a -2. Okay, so here it's not balanced. it has to equal basically 0, right? So how many, okay, wait, I'm going to back up here. So potassium and iodine, if I wanted to write the chemical formula for that, I'm sorry, you would just write the symbol. I only have one of those, and then iodine. So it's just Ki. A little frazzled here. Okay, so because I just need one potassium, I have my 1K, and just because I need my one iodine, I just put my I. So Ki. That's how I would write the chemical formula for this binary ionic compound. Sodium, sulfur. Okay, so sodium is a +1, and sulfur is a -2. So the charges don't balance out. So what can I do to get them to be equal? Well, I need 2 sodiums. Okay, because then with my 2 sodiums, I'm now at a +2. And now my +2 equals my -2. So when I write this, I'm going to write Na, that's the chemical symbol for sodium, but I needed 2 of them, so I'm going to stick a little 2 down here, and then sulfur, Na2S. Aluminum, +3, and oxygen, -2. All right, so aluminum +3, oxygen -2. What's a common number that both 3 and 2 go into? And you want to pick, obviously, the least common number, right? Lowest. 6, right? So how many times do I have to multiply 3 to get the 6? 2. How many times do I have to multiply 2 to get the 6? 3. So when I write this, it's going to be Al2O3. And the charges equal out. Now when you name binary ionic compounds, you say the cation of the element. Okay, you just list the element, and the second name is the anion, and you drop the end in and you change it to IDE. So I'm going to change to my select here so I can type. So here I have sodium and chlorine, right? So the rules are, you just say, come on now. Jesus. Okay. Wow, we got some lag time here. Deep breaths. Sure, I'll take it. Nope. Okay. It's like a lag time of 5 seconds. Well, should have just kept to my pen, huh? Okay, so sodium. So I just write sodium, I leave it alone, and then for my anion, it's not chlorine, it's chloride. Okay? Take a look at SrF2. So Sr on my periodic table is strontium. It's in group 2, element atomic number 38. So I just type out the cation as is, strontium, and then that F2, that's fluorine. But I'm not going to say fluorine, I'm going to say fluoride. And I spelled it wrong. Awesome. Still spelled it wrong. Here we go. Fluoride. All right, take a look at Al2O3. Okay, so here's my cation. It's always listed first. I'm just going to say aluminum. Aluminum. And then that O3 is oxygen. And I'm going to change the end into oxide. Okay. Let's go. Come on. Start the clicker. Okay. I hope this is the right page. Better check. Huh? Jesus. Yeah. No. Okay. This is taking longer. Okay. Here we go. So the stock system of nomenclature, some elements such as iron, they tend to form 2 or more cations with different charges. So when you get to the D block elements, The D blocks, that their charges can vary. It could be +2, it could be +3, it could be +4, and it's all because of those sea of electrons. So to distinguish those ions, we use something called the Stock system of nomenclature, where we're going to use a Roman numeral number to indicate the ion's charge. So if my iron has a +2 charge, then that name for the +2 is going to be iron, and then you put the Roman numerals in parentheses, Roman numeral 2. Or if the iron ion has a +3 charge, then you say iron, Roman numeral 3. So sample problem, write the formula and give the name. You know what, I'm just going to use my pen because that seemed to be faster. Write the formula and give the name for the compound formed by the ions Cr +3 and fluorine. So right off the bat, you take a look at the charges and you can see that those charges are not balanced, right? I have a +3 over here and a -1. So what do I need to do to get them to equal 0? Well, I'm going to have to take my fluorine and multiply it by 3, right? So I can get a -3 charge to balance out the +3 charge. So let's write the formula first, okay? So I'm just going to say Cr, and then fluorine, and I had 3 fluorines. That's it. Okay, now I have to name it. So the cation's just the name of the element. Cr is chromium. Okay, that's an M. Jesus. Okay, and then F3, well, hold up. So chromium is in that D block, okay, and it's got a +3 charge. So I'm going to say Roman numeral 3. And then fluorine, we change the ending of that anion to fluoride. So chromium, Roman numeral 3, fluoride. Okay, name the ionic compounds. So copper is in that D block, right? So I'm going to say copper, but it's in that D block, which means I'm probably going to need a Roman numeral because copper can be +2 as well. Well, you're like, well, how do I know the charge of it? Well, take a look at the anion. Here I have chlorine, and chlorine's a -1, but I have 2 of them, right, for an overall -2 charge. Well, with the copper, I only have 1 copper. So what's the charge of copper got to be? It's got to be a +2. So copper, Roman numeral 2, and then chlor, and you change the ending to IDE. Okay, lead O2. So Pb is also in the, no, it's not. Pb is a group 14, okay, but I think lead has some unique abilities as well, but we'll see. Yeah, let's just put the Roman numeral on it. So here we have oxygen. Oxygen has a -2 charge, but I have 2 of them for an overall -4 charge. So what is the charge of lead? Well, I only have 1 lead, so it's got to be a +4. So I'm going to say lead, and I think you need the Roman numeral on this one. So if it's D block, for sure you need a Roman numeral, but I'm pretty sure this is a Roman numeral one. And then we change the ending of oxygen to oxide. All right, COI. So we have cobalt and iodine. So cobalt's in the D block. Iodine is group 17. It has a -1 charge. Cobalt means that it has a +1 charge. Because it's in the D block, I know for sure that I'm going to need a Roman numeral. So I'm going to say cobalt, Roman numeral 1, and then I'm going to put iodine down here. Okay, write the formula and name for the following compounds. Copper +2 and bromine. So first thing we do with the formula is we got to make sure the charges are equal. So I have a +2 over here, -1 here. Geez, they're not balanced. How am I going to do that? Well, I need 2 bromines to get to a -2. net charge. So then I just write copper because I just have one of those, and then bromine, and I need 2 of them. And then I have to name it, right? So it's nice when they do this because you know it's a +2. Copper's in that D block, so we need a Roman numeral. So I'm just going to say copper 2. And then I change the ending of bromine to bromide. Okay, over here, iron's a +3 and oxygen's a -2. So the charges don't balance. What's the least common number that they have in common? That's going to be 6. So how many times am I going to have to multiply 3 to get to 6? 2. So 4a + 6. How many times am I going to have to multiply this -2 to get to a -6? That's 3, or an overall -6 charge. So now they are balanced and canceled out. So when I write this, I go Fe, and I have 2. Don't put the charge. That's a common mistake. You look at how many you had to multiply it by. So it's going to be Fe2. It's really bad too. And then O3. And when I go and name this, it's iron. And then I take a look at the charge on this. It's a +3 charge. So Roman numeral 3, and then oxide. So I know that is a common mistake in chemistry. They think the charge, is the subscript. No. The charge is the Roman numeral, and then how many times you have to multiply it is the subscript. Okay, I think that's my last slide, yeah. So I know I threw a lot at you there, and I think I might have an assignment. Just check Google Classroom.